Hi there, I'm Suzanne Kieffer. On behalf of my co-authors, I'm pleased to present our paper, Invisible Risks in Virtual Reality, Raising Awareness of Profiling and Overengagement through Lecture and Storyboard Interventions. Most risks in immersive technologies are invisible, not because they do not exist, but because users cannot perceive them. These risks are often framed in technical or legal terms that remain confined to expert circles. We define invisible risks as threats that undermine users' agency and ultimately their autonomy. Agency refers to users' situated sense of control over actions. Autonomy refers to their structural capacity to make free and informed decisions. In this paper, we focus specifically on virtual reality. We examine two invisible risks in VR, profiling and overengagement. Profiling refers to opaque data extraction and inference processes that make user behavior legible to the system. Overengagement refers to immersive attentional capture that constrains the ability to disengage. Together, they represent complementary mechanisms through which VR systems can undermine agency. Why VR? Why these risks? This table maps 16 academic sources, comparing their coverage of 5 invisible risks: privacy, surveillance, profiling, behavioral manipulation, and overengagement. These risks are analyzed across 4 immersive modalities: XR, VR, AR, and MR. Full circles indicate risks or modalities that structurally frame the paper. Half circles, secondary mentions. The absence of circles signals the topic is either not addressed or marginal. In this mapping, VR is the most documented and mature immersive context. It provides a fully immersive environment where embodiment, presence, and behavioral adaptation are intensively studied. Within this landscape, profiling appears as a foundational invisible risk in both XR and non-XR systems. Meanwhile, overengagement appears amplified in VR due to continuous interaction and perceptual immersion. Our research question is the following: how can invisible risks in VR be made perceptible and meaningful to users? We hypothesize that emotions can raise awareness of such risks. VR users may not explicitly recognize or articulate invisible risks during use. Emotions, therefore, function as early signals. They redirect attention and indicate that something is at stake, even before users can clearly name the underlying mechanism. Awareness matters because without it, there can be no evaluation or resistance. To investigate this, we designed 2 narrative interventions. First, a traditional lecture presenting various VR-related risks. Second, design fiction storyboards focusing specifically on profiling and overengagement. The storyboards introduce 2 characters, Alex and Kelly. We display 3 representative panels for each character. Alex encounters profiling mechanisms where personal and behavioral data are inferred and reused without clear awareness. Kelly progressively becomes overengaged, sacrificing social ties and losing the ability to step back. These narratives aim to make abstract VR mechanisms concrete and emotionally tangible. Our research involves two studies conducted at different times in which participants experience a baseline VR condition without any explicit risk framing, and then, depending on the study, the awareness intervention. In Study 1, the VR baseline is followed by the lecture. In Study 2, by the storyboards. We collect quantitative measures of emotional responses, engagement, and perceived cybersecurity risk. We also collect qualitative participant comments. Our first result shows a clear emotional shift following the interventions. The bar charts display the distribution of participants' dominant emotion across conditions. Study 1 contrasts the VR baseline with the lecture, and Study 2 the VR baseline with storyboards. The VR baseline mainly elicits surprise and enjoyment, reflecting novelty and positive engagement. But once risks are introduced, emotional responses diverge clearly. In Study 1, the lecture triggers fear. In Study 2, Alex triggers fear and disgust, associated with concerns about invasive data practices and ethical violations. Kelly triggers sadness and disgust, associated with perceived loss of agency and social disconnection. These shifts suggest that emotions do not merely reflect intensity, but different ways of interpreting invisible risks in VR, cognitively, affectively, and morally. The second result concerns overengagement. The bar charts display participants' evaluations of their own VR experience with their evaluation of Kelly's across 4 engagement dimensions: aesthetic appeal, focused attention, perceived usability, and reward. Participants evaluate Kelly as highly focused and persistent, yet not rewarded. Focused attention increases, while perceived reward decreases. Engagement is no longer associated with enjoyment, but with pressure and inability to step back. This combination, high attention, low reward, captures overengagement in VR as constrained immersion and diminished self-regulation. The third result concerns profiling. The bar charts display perceived privacy and cybersecurity risks across 4 dimensions: data collection, consent, hacking, and cyber attacks. After Alex, perceived risks increase across all dimensions. Participants reassess the VR system as intrusive and potentially harmful. Comments shift from "I'm not worried" to explicit concerns about data misuse and cyber attacks. Here, awareness takes the form of explicit risk recognition rather than emotional judgment. Our findings show that awareness in VR is format-dependent and multidimensional. Emotional responses often precede recognition. Profiling and overengagement produce distinct awareness dynamics: discovery-driven versus judgment-driven awareness. Finally, designing VR system also means designing for perceptibility. Thank you for watching.